Hi, friends. Welcome to E-Concepts. Wind, though invisible, is a powerful natural force that shapes landscapes, moves oceans, and today drives modern energy solutions. Across the world, humans have learned to harness this invisible energy using wind turbines. In this video, we'll explore how turbines work, the different types used today, where they are applied, and the innovative technologies shaping the future of wind energy. Let's start with the most common type, horizontal axis wind turbines. These are the classic turbines with tall towers and three long blades, spinning like a giant fan facing the wind. Their working principle is simple yet effective. When wind hits the blades, it generates lift, similar to the aerodynamic forces on an airplane wing, causing the rotor to rotate. The rotor turns a shaft connected to a gearbox, which increases speed from around 15 RPM to nearly 1,500 RPM. This high-speed shaft drives a generator, producing electricity. The power then travels down the tower through cables to a transformer and finally into the grid, supplying homes and businesses. Modern horizontal axis wind turbines usually stand 80 to 120 meters tall, with blades 40 to 60 meters long, generating 1 to 12 megawatts, enough to supply roughly 5,000 homes. These turbines come in two main designs, upwind and downwind. Upwind turbines face the wind, are efficient and quieter, but they require a yaw system to keep facing the wind. Downwind turbines align naturally with the wind, though the passing blades create turbulence and extra noise known as tower shadow. Horizontal axis wind turbines are highly efficient, reliable, and capable of very high power output, 2 to 15 megawatts with new models exceeding 20 megawatts. However, they need open spaces, strong winds, tall towers, and long blades, and are less efficient in turbulent conditions, such as cities or valleys. Now let's move to vertical axis wind turbines. Unlike horizontal axis wind turbines, vertical axis turbines rotate around a vertical shaft like a spinning coin, allowing them to capture wind from any direction without a yaw system. Wind pushes the blades, rotating the turbine and driving a generator placed at the base. There are two common types of vertical axis turbines. Darius turbines have curved, egg beater-shaped blades and use lift, reaching up to 80 to 90% of a horizontal axis. Wind turbines speed, though they require an external motor to start. Savonius turbines use drag, are slower but reliable, and ideal for low wind speeds and small applications like water pumps or rooftop power. Vertical axis turbines work well in turbulent urban environments, are easy to maintain due to ground-level generators, and do not need to face the wind. However, they are generally less efficient and not suitable for large commercial wind farms. Next, let's look at bladeless wind turbines, a futuristic concept. These turbines do not spin. Instead, they vibrate. Slender poles oscillate when wind flows around them, creating small, swirling air pockets called vortices. The mast vibrates at its natural frequency, and a generator converts this motion into electricity. Small bladeless turbines produce 50 to 100 watts, with larger versions in development. They offer low maintenance, minimal noise, and strong suitability for urban areas. But output is currently low, and the technology is still experimental. Now let's move offshore to floating wind turbines, designed for deep waters where fixed foundations aren't feasible. A horizontal axis wind turbine is mounted on a floating platform, stabilized with buoyant structures, heavy anchors, and tensioned cables. The platform moves slightly with waves, but advanced control systems keep the turbine steady. Floating turbines operate in 50 to 1,000 meters of water and produce 8 to 15 megawatts per turbine. Offshore winds are stronger and more consistent, allowing high energy output. Floating turbines reduce the need for heavy seabed foundations and can be placed far from shore, though installation is costly and engineering is complex. Finally, the wind energy industry is rapidly advancing. Engineers are developing giant 20-plus megawatt turbines with rotors 250 to 300 meters in diameter. capable of powering entire communities. Smart blades with sensors adjust automatically to reduce fatigue and extend lifespan. Hybrid solar wind towers capture both energies, and offshore wind farms are producing green hydrogen for clean fuel. Next-generation multi-rotor vertical axis wind turbines, advanced floating platforms, and scaled-up bladeless turbines are also emerging. Together, these innovations point to a future where wind power is more efficient, versatile, and central to global clean energy. That's all for today. I hope you enjoyed the video. Thank you for watching.